Alright, number 13. He defined where the slope of the curve is defined. Alright, so what we're going to do is we're going to take the first derivative of each one of these, and we're going to see where it might not be continuous, or might have some zero division, or square root of a negative, that sort of thing. So number 13, we're looking at the curve x squared y minus xy squared equals 4. I'll just go ahead and take the derivative of it. Remarkably similar to the first question we did. So that would be the first times the derivative of the second, second derivative of the first, first derivative of the second, plus the second times the derivative of the first, minus, all this is that part. So minus the first times the derivative of the second, plus the second times the derivative of the first. Equals 0, because the derivative of 4 is 0. So let's clean it up, keep the dy dx on the left hand side. So that would be x squared dy dx stays. This 2xy goes over here. And this stays. That's 2xy dy dx. This has to go. It's already negative, so we can just add it to both sides. And we're pretty happy. That means that dy dx, oops, it's factored out, x squared minus 2xy. We have negative 2xy plus y squared. Divide both sides by this, so I'm just going to write it over there. X squared minus 2xy. Alright, there's our derivative. So dy dx equals negative 2xy plus y squared. So it's really y squared minus 2xy. And x squared minus 2xy. And so this is defined every place that this does not equal 0. Let's see how the book wants us to set this up. Let's see here. Number 13. Alright, so every place this does not equal 0. So let's set it equal to 0 and see when that is. So x squared minus 2xy equals 0. We factor out an x minus 2y equals 0. And that 0 in either one of these is 0. So when x equals 0, that's the place where this is not defined. And where x minus 2y equals 0, another place where it's not defined, which is where x equals 2y, or y equals x over 2. I guess we'll say y equals x over 2. Or y, x equals 2y, either one. But these are points or lines, as the case may be, where dy dx is not defined. Number 15. Same idea. We'll take the derivative of the function, find out where it is not defined, and be good to go. So that's x cubed plus y cubed equals xy. Take the derivative with respect to x, gives us 3x squared plus 3y squared dy dx equals the first times the derivative of the second plus the second times the derivative of the first. Alright, so that's how we have to do chain rule, first, second. dy dx is to the left, 3x squared to the right. It'll be 3y squared dy dx minus x dy dx equals negative 3x squared plus y. We just changed some things around. This stayed, this went, this came over this side, this stayed. Alright, so that would be dy dx. Backed it out of 3y squared minus x equals, and we'll just switch these around because it looks nicer with y minus 3x squared. Divide both sides by this, so it'll be 3y squared minus x. And so there we have dy dx equals y minus 3x squared over 3y squared minus x. Where this is not defined is where 3y squared minus x happens to equal 0, or where 3y squared equals x. Our function's first derivative, well, yeah, first derivative not defined. All right. Number 17. Define lines that are tangent and normal to the curve at a given point. So we've got x squared plus xy minus y squared equals 1 at the point 2, 3. We'll take our derivative. That'll give us our slope once we evaluate it at 2, 3. And we'll get our tangent line. So that would be 2x plus first times the derivative of the second, plus the second times the derivative of the first. There's a 1 here, but I'm not going to write it. Minus 2y dy dx equal to 0, so the derivative of 1 is 0. Alright, so we've got x dy dx minus 2y dy dx. Both of the terms that stay on this side. This term goes on the other side. Factoring out dy dx equals, factoring out, not dividing it, x minus 2y equals negative 2x, and then dy dx, after we divide both sides by x minus 2y, will be negative 2x over x minus 2y. So that's our slope at point 2, 3. So we want to evaluate this 2, 3. So the dy dx evaluated at 2, 3. It's going to be negative 2 times 2 over 2 minus 2 times 3, negative 4 over negative 4. That's convenient. It's 1. Alright. That's the slope of the normal line. Slope of the tangent line, slope of the normal line will be the negative reciprocal, which would just be negative 1. So we've got tangent and normal lines. Do y equals mx plus b up here. So that's going to be y equals 1x plus b. Normal line will be y equals negative 1x plus b. And so the tangent line at 2, 3 is going to be 3 equals 2 plus b. B equals 1. Gives us y equals x plus 1. The normal line, 3 equals negative 2 plus b. B equals 5. So y equals negative x plus 5. All right. Number 19. X squared y squared equals 9. I wonder what that looks like. X squared times y squared equals 9. Well, we'll figure out the parametric version of this as extra credit later. But for the meantime, we'll just take the derivative and do as we're told. Alright, so we got product here. So the derivative is going to be the first times the second plus the second times the derivative first. And there's only one dy dx, which is very nice. Well, glad to get our point of normalcy and tangency. There we go. So that would be, let's multiply that's added. So the first thing we're going to do is say 2x squared y dy dx. Just rearranging this a little bit. Equals, and then it's going to be minus. That's minus 2xy squared. So we just subtracted this from both sides. Divide it out. Dy over dx equals negative 2xy squared all over 2x squared y. Let's have some canceling fun. X and the x squared cancel, 2 and 2 cancel, y and the y squared cancel. That leaves us a negative y up top and an x down at the bottom. And evaluating this at negative 1, 3. We find that would be negative 3 over negative 1, which just equals 3. That's our, right off there. Evaluated negative y over x using this y and this x. That's negative 3 over negative. Whoops. Sorry about that. Alright, so 3 was the tangent. Tangent y equals 3x plus b. And that means that 3 equals negative 3 plus b. So b equals 6. So that gives us y equals 3x plus 6. Tangent line, normal line, y equals, instead of 3, we're going to use negative 1/3. Still using 3 and negative 1. So that would be 3 equals 1/3 plus b. And so b equals 8/3. So y equals negative 1/3 x plus 8/3.